There are two ways a big rocket can experience the extreme cold and vacuum conditions of outer space. One is to send it about 145 miles up that way. The other is to bring it here, to the Space Power Facility here at NASA Glenn Research Center's Plum Brook Station. This is the largest space simulation chamber in the world. It's 100 feet in diameter and over 120 feet high. During testing, the air is removed from the chamber by a series of powerful vacuum pumps. Temperatures can be brought down to just above absolute zero, and even the sun's light and heating effects can be recreated. This requires a lot of power, and we've got it, up to 12 megawatts, enough for a small town. Other than zero gravity, we can duplicate conditions anywhere in or out of the Earth's atmosphere. Because of its extraordinary features and capabilities, the Space Power Facility has been selected as the site for some of the most important and biggest test research in America's space program. Fairing separation tests ensure valuable payloads such as communications, Earth-observing, and scientific satellites are protected during launch and released safely and successfully into orbit. International Space Station tests support the deployment and performance of specially designed radiators that cool both people and critical space station equipment. Impact experiments on the Mars rover airbag helped develop the design that allowed the rover and its precision equipment to land softly and safely on the Martian surface while impacting at 60 miles an hour. The Space Power Facility is especially suited for optical telescope testing, not only because it is large, but also clean, stable, virtually vibration-free, and can be made very cold. Test preparation starts right here in the Space Power Facility's assembly area. Big equipment is carted in through these doors on as many as 3 sets of tracks that support up to 300 tons. The test article is readied in the high bay area and can be transferred to the vacuum chamber on these tracks. So any assembly and fine-tuning can be done easily right here before the test hardware is moved into the chamber. This is another unique feature of the Space Power Facility. The assembly area and test chamber can be set up to be totally contaminant-free, which is critical for space optics testing in what's called a Class 10,000 clean room. We have an on-site shop area with machining capabilities and a skilled workforce to provide support during the test buildup. The heart of the facility is a chamber within a chamber. The outer chamber has concrete walls 8 feet thick to hold up the atmosphere above it. Space conditions can then be created in the inner aluminum chamber. The air is pumped out in stages. It takes 2 to 3 hours for these roughing pumps to pull 97% of the air out of the inner and outer chambers and create what we call a rough vacuum. Having created the rough vacuum, we switch on advanced cryogenic pumps, which take an additional 6 to 8 hours to create a hard vacuum, or true space-like conditions in the inner chamber. 10 of these pumps are mounted on gate valves. We're able to isolate each one from the chamber. This state-of-the-art, clean, high-vacuum pumping is ideal for optics testing. The chamber is supported by 88 of these columns and locked in place in the center by a concrete buttress. This design allows for contraction and expansion of the chamber as it goes through dramatic temperature fluctuations. In turn, the columns are mounted to a 12-foot thick slab of concrete with 30-foot tension pods going down into the bedrock. This makes the chamber extremely stable when it comes to vibration in what we call the micro-G range, ideal for optics testing. The test article is moved into the main chamber from the high bay area we saw before. It's hoisted, positioned, and stabilized by a 20-ton crane at the top, with 2 hooks that run the full circumference of the chamber. No other vacuum chamber has this feature. Cryogenic shrouds are used inside the vacuum chamber to simulate the cold conditions of space. The ends can be covered with panels through which liquid nitrogen or cold helium gas can be pumped, producing any temperature or range of temperatures that a vehicle would encounter as it travels through the atmosphere and out into space. When the test article is ready to go, we shut the vacuum chamber. First, the 50-foot by 50-foot door on the inner chamber is closed. Then the outer chamber door is closed. It is 8 feet thick, 50 feet tall, and 50 feet wide, and is moved across this opening with a hydraulic actuator. When they're shut, the chambers are completely sealed off, pumped down, and just a few feet away, it's like being a million miles out in space. The control room at the Space Power Facility is designed to provide the ultimate in flexibility, along with capabilities that can handle even the most unusual tests. Plumbrook staff experts assist customers in data acquisition and provide any other technical support necessary. Once the test is completed, the equipment can be brought out through a smaller door on the other side of the chamber, or it can come back out here through the large assembly area door. Before spacecraft or space components go to Mars, the Moon, deep space, or any place in the Earth's atmosphere, they may first come here to Plumbrook's Space Power Facility, the largest space simulation chamber in the universe.